Europe has big plans, vast progresses with the space station, Starship Flight Test 6 100% success, ABL stops commercial rocket business, launches of the week. I'm Christophe Paget from All About Space, and this is your Space Update. Europe has been expanding its ambition to grow exponentially with a new call called Preliminary Elements on European Reusable and Cost-Effective Heavy Lift Transportation, or PROTEIN for short. In 2023, ESA commissioned ArianeGroup and RFA to study how Europe could acquire a launch capable of sending payloads over 100 times heavier than it can today, making the vehicle a super heavy launcher from 70 metric tons minimum. The primary aims are to transport heavy modules to space for a solar electricity generator and a data center. ESA's PROTEIN study challenged companies to evaluate the feasibility of a rocket and the necessary ground infrastructure to support such ambitious launches and show how it could be achieved technologically, while pinpointing areas where resources or technology might need more development. The study concluded that developing such a rocket within the next decade would be challenging and would require early start of technology developments, as well as considering all aspects such as infrastructures, funding, and legal framework, and I may add, political will. The ambitious target set by ESA was to send up to 10,000 tons of cargo to low Earth orbit per year, with a payload cost of €280 per kilogram max, with the minimum environmental impact as early as 2035. To achieve such an ambitious goal, the RFA design uses reusable stages and fairing, with a rocket having 2 to 3 stages depending on the lift needs. The concept looks very much like a cross between a Falcon 9 and a Starship. I mean that the first stage would be landing in the same fashion as a Falcon 9 with landing legs, whilst the second stage has 4 fins allowing landing using the belly flop maneuver of the Starship. The two-stage version is 130 meter tall, 7 meter in diameter, and capable of launching to low Earth orbit 70 tons with a first stage return to site, or 100 tons for a first stage landing on a ship downrange. As for the 3-stage rocket, it is 100 meter taller and capable of sending to low Earth orbit 15 to 30% more payload. The first stage is expected to use 30 reusable Prometheus engines running on Methalox, whilst the second stage will run on Hydrolox. I leave you in the comments the links for such a study. The ArianeGroup concept is similar to RFA's for the first stage, however, they only expect a return to site of the booster. The second stage would also be reusable based on the SUSI project already funded by ESA. However, ArianeGroup also proposes a non-reusable second stage for better performance when needed. Prometheus is also the engine selected in this rocket. The rocket, expected to be up to 134 meter tall and up to 9 meter in diameter, would be capable of sending 100 metric ton payloads to low Earth orbit, slightly higher than that of RFA, in the case of first stage returning to launch site. In both studies, Europe Spaceport in French Guiana would be the preferred choice for erecting such a large launch pad. VAST, an American startup formed only 3 years ago, has the ambition to build a space station based on modules like the ISS, a module called Haven 1, with the aim of running microgravity research, development, and manufacturing experiments. VAST contracted SpaceX Falcon 9 to launch its first module to space in 2025. Part of that agreement with SpaceX also include the use of Starlink laser communication system aboard the VAST station, the one tested on the Dragon Polaris Dawn mission back in September 2024. VAST has progressed significantly in the past month, where you could see the Haven 1 structure reaching completion. There is a long way to go until the module is ready for launch in 2025, but I will continue bringing you updates on their development to you. At Starbase, at the production site, the booster number 16 is getting a liquid oxygen tank section, the last before one section. And at the launch site, SpaceX is in full preparation for his flight test number 6, with checking that all equipment is working as it should be, such as the grid fins here, the flaps, and also they have installed the explosives on the booster and Starship for the flight termination system. The Starship stack has then undergone a wet dress rehearsal. All was set for the flight test number 6, which occurred in the afternoon on November 19th. The rocket took off on time with on board a healthy cargo, a banana. I'm not sure what the joke is, but it's funny nonetheless. The rocket cleared the tower and did some damage on the pad on the way. It then reached Mach Q and reached supersonic speeds in less than a minute. It then went on to an altitude of 68 km with hot staging separation of both stages. The booster number 13 came down in the same fashion as for the previous flight, test number 5, except that the tower has had an issue during takeoff, which forced the decision from SpaceX to abort the catch attempt and soft landed in the Gulf of Mexico nearby. The booster exploded shortly after, as expected, since the rocket is not designed to land on water. It was then not clear if parts of the chimes came off or the engine nozzles were warped as in the previous flight. The second stage Starship number 31 engines kicked off to bring the Starship to its planned 190 km altitude. The cruising flight went well and even demonstrated engine relight for deorbiting purposes. The Starship then started its descent through plasma re-entry, where we could see these wonderful colors generated by friction. What could be observed is that some heat protection tiles did come off during re-entry and even went on to collide with parts of the structure in the aft section. Additionally, a part of the forward flap section came off, exposing the flap with hot plasma. This flap was already subject to damage in the previous flight tests, but not in this particular area. In the next flight tests, the Starship will be number 33, a version 2 which has forward flaps further away from the plasma flow and therefore likely to be less of an issue. Now, time will tell. The Starship then soft landed in the Indian Ocean, this time in daylight, giving us an amazing picture of accurate soft landing. ABL is an American startup born 7 years ago with the ambition of building a small launch rocket called RS-1 with payload to low Earth orbit up to 1 metric ton. His business case was based on launching rockets from anywhere around the world, with all his mobile infrastructure fitting in shipping containers, an attractive characteristic if you are a military customer, but not so if you are a civilian one, as it's still a headache to get launch licenses wherever you wish. ABL has lost his first 2 rockets so far. The first one launched in January 2023, but exploded meters above the pad, whilst the second rocket suffered an explosion during pre-flight testing in July 2024. Although ABL has managed to raise $500 million in funding, it gave up the fight and decided to leave the commercial launch market and devoting his effort to the military missile market instead. The ABL founder and president Dan Piemont said on X.com that the company decided to pivot because of changes to the launch market where meaningful impact in the launch industry has diminished. So basically, the market is too crowded. He also mentioned that missile defense is a major area of investment for the US Department of Defense, so it will be therefore the last time I will be talking about ABL. I thought funny to show you what SpaceX put side by side, which is the Starship booster catch simulation on the left, released several months ago, synchronized with the footage of the booster number 12 during the flight test number 5 catch attempt at Boca Chica on October 13th. You must admit it's a very good simulation. The slight difference comes from the fact that SpaceX has not taken the direct path to the tower, but rather a path allowing some safe crashing away from the infrastructure in the event of an anomaly, which nearly happened, by the way, when part of the chimes was removed during descent. So well done, SpaceX, for this achievement. November 15th, CASC launched a Long March 7 from China for its cargo resupply mission Tianzhou 8, carrying 7.5 metric tons of goods to the Chinese space station Tiangong. The craft docked successfully to the station 3 hours later. November 17th, SpaceX launched a Falcon 9 from Florida for its mission TD7 Optus X. The first stage flew for its 16th time and landed on a drone ship. November 18th, SpaceX launched a Falcon 9 from California for its Starlink mission Group 912. The first stage flew for the 20th time and landed on a drone ship. On the same day, SpaceX launched a Falcon 9 from Florida for its mission GSAT N2, previously planned on an Indian rocket which could not meet the weight needs and timelines. The first stage flew for the 19th time and landed on a drone ship. November 19th, SpaceX launched a Starship from Texas for its flight test number 6. The first stage, booster number 13, was brand new and did a soft landing in the Gulf of Mexico. As for the second stage, Starship number 31, it has soft landed on water in the Indian Ocean. November 21st, Roscosmos launched a Soyuz 2.1A from Kazakhstan for its cargo resupply mission Progress MS-29 with 2.4 metric tons of goods. On the same day, SpaceX launched a Falcon 9 from Florida for its Starlink mission Group 666. The first stage flew for the 20th time and landed on a drone ship. In summary, from January 1st until November 21st, 2024, 222 rockets were launched successfully. Out of that, 138 were from an American company or institution, 55 from China, and 14 from Russia. I leave you this week with this image of the IC-348 and Barnard 3 near the bright star Omicron Persei. It's a colorful composition of dust, gas, and stars some 1,000 light years away from us. Omicron Persei is located in the bluish halo of dust, and the young star cluster IC-348 immediately below it. In silhouette against the diffuse reddish glow of hydrogen gas, dark and obscuring interstellar dust cloud Barnard 3 is at upper right. I am Christophe Paget for All About Space. See you at the next episode of Space News.